So this is a self-driving car simulation project that I've been working on, and I'm just gonna quickly go over what a convolutional neural network is because that's what the car uses to be able to recognize image and just do basic image analysis. Um, I don't know how to work with animation, so I'm just gonna I just have found a website. I'm just gonna link in the description that actually shows accurately what a convolutional neural network is actually doing. So you can see here. So these are just this over here is the input, where the input is broken down into the red portion, green portion, and the blue portions. And what's essentially just happening is a matrix-wise operation with filters in each layer. So each layer can have up to 8, 100 filters, whatever. And each filter essentially is the weight. So in a normal neural network, the weights are the lines. You can kind of just think about filters as the exact same thing, where they're just multiplying with their local receptive field wherever they're looking in the given input, and they calculate an output based on that. You can read about it by yourself. It's a pretty good read. So now I'm going to show you what the convolutional neural network actually looks like. So I actually plotted it. So this is an image here. The only convolution part is up here, sequential 26, where the input is 1 by 3 by 50 by 50. The first one just represents just the fact that there's only one image. Maybe you want to send in some kind of a video feed, and that one could be like 5 or something. 3, the number of channels, the red, green, and blue, and each of them are 50 by 50 pixels. And after the convolution part is done, it just collapses down to a 1 by 800, just 800 neurons. Pretty simple. So this part over here is the input, the velocity of the car, just 1 by 1, and it outputs to a 1 by 512, which in my opinion is just overkill. I could have just changed that to like a 10 or something, but whatever. And both of these merge together. Both these inputs essentially just merge into a 1 by 1312. So we just do 800 plus 512 is 1312. So after that point is where the real multilayer perceptron starts, which is just lots and lots of 512 neurons, each in their own layers, each in their own hidden layers, and it outputs down to a 1 by 3. So 3 is the output. Do we want to go left? Do we want to stay? Or do we want to turn right? So now I'm going to show this the setup. Essentially, I'm using Keras for Python to do all the training and prediction for the neural network. So what's actually happening is the Unity is using C# and it's essentially just running a server. So this server is just waits for Python to connect through a client. So Python essentially just asks for data, basically just says, give me the image and give me the input and I'll predict something out of it. Now I'm going to show the car in action. So first thing I'm going to do is just start the server. So it started. Now I'll start the client. So let's start. So the blue line here just means how much it wants to turn left. The red line is how much it wants to turn right, and the green line is how much it doesn't want to do anything. Just keep going straight, basically. So they're just probabilities. So that's what the output represents. Just a probability from 0 to 100. Well, technically 0 to 1, but multiplied by 100. And whichever probability is the highest, that's what the car chooses. And essentially that's what we're training it with, right? From my own inputs, when I press right, all other, that means I 100% I want to go right, and all other outputs become 0. And if I don't do anything, then the middle one becomes 100% because I just want to keep going straight. And same thing with going left. So that's essentially how this neural network is trained. So this particular neural network was trained with around 4,000 data images. So in 2 different data sets. So each data set had around 2,000 images. So this car is actually really good at staying on track. It can clearly identify curves. It can clearly identify straight lines. So it knows what it's doing. And I can even ramp up the speed and it will still stay on track. I'll increase the speed to 75 and change the downward force to 1,000. So now it really gets going. So this is not sped up. This is just the neural network has to make that quick decisions. So now I'm going to show you what the data actually looks like. So the data folders 23 and 24 were used to train that red track. So there's about 1,900 images in here, as you can see. So each dataset is accompanied by a raw data.txt file. So let me open that up. Okay. So this first entry here is for image 0. This first number is the car's velocity for image 0, and the last three inputs are the output to the correct output for the neural network to guess. So the 0 means it's not turning left. 1 means in the middle. Since the 1 is in the middle, that means the car just has to keep going straight. I think I can find. So let me try to find one. Okay. So for image 106, let me go to 106. I was turning right, since you can see the third entry in the output is 1. So for image 106, I was turning right. So it makes sense. I was next to a curve and I was turning right. So essentially, this is how the neural network is trained. It's pretty simple, and the neural network just has to learn to match these images to their corresponding outputs, and that's how I can learn whether it should be turning left or right. So now I'm going to showcase what the neural network is actually seeing. First of all, at the bottom here, it's just a GIF of the car driving. I just took a whole bunch of pictures. It was just as the car was driving, it was just taking a whole bunch of pictures. And what you see up here, it says layer 6. So the convolutional neural network actually has 6 layers, and the 6th layer actually has 32 filters. So I've just picked 2 filters at random, filter 1 and filter 17. And we can see that they both have a whole bunch of activations, the blue parts. So what's actually happening is they're going through a process called hierarchical modular decomposition, which just means make the pixels brighter for the areas that this filter is having high activation for. So we can actually look at it and see what this filter finds important in this given image. So we can see that filter 1 has a high response to curves. It doesn't like responding to straight lines at all, whereas filter 17 responds to curves and to straight lines, but it mostly likes responding towards the left side. The right side doesn't have as much of an activation as the left side does. So filter 17 also seems to like responding to the car, whereas filter 1 doesn't respond to the car at all. The car is practically invisible to filter 1. These activation points are eventually fed into later layers, or into the actual multi-layer perceptron that's connected to this convolutional neural network. And that's where, after a little while, that's where the prediction comes, whether you want to turn left, whether you want to turn right, or whether you want to keep going straight. It all comes down to where the filters find their activation and where they think is the most important part in that image. Now let's see how it does on a completely different track. I assume it's going to be fairly decent, because really at the end of the day, this neural network has learned to do edge and curve detection, so it shouldn't be too bad. Yeah, it's doing alright. But the difficult part is going to come up at front, because right about now the camera won't be able to see the car. So let's see how it does then, because the camera is going to be above another elevated track. Yep, there it goes. It fell. So this neural network clearly doesn't know what to do when the car suddenly becomes invisible, or all of a sudden it has to make a decision because it can't see the immediate track in front of it. Now I'm going to change the weights file to a different weights, so _2. So it's the same model, the same neural network model, but the weight is different. So this weight file was trained on this specific track, whereas the other weight file was trained on that other track. So this one should do a lot better. It actually, so I've only trained it to be able to drive on the left side. It can't drive on the right as well as it can drive on the left. Oh, here comes the difficult part. Can it drive? Yes, it can. So it's making decisions. So it's looking at every part of the image, even in front of it, even behind it, even immediately on it. Come on, don't fall off. Okay. So it's not perfect, as you can see. Well, that's the amazing thing about these types of neural networks. They only get better with more training data you give it. And I've just been lazy. I've only trained this for I think about 30 minutes. If I trained it longer with more training data, it would be amazing. It would have been amazing. But overall, it's pretty good, I would say. It can drive on the left side fairly accurately. As long as it doesn't fall off, I'm okay with it. Nope, now it has to go downhill. Good. Alright, so now it's back where it started, pretty much. So the future of this project, I'm actually thinking about adding things like lane signals. So I want the car to be able to drive on both sides of the lane properly without even remotely like going near the edges. So it's going to be a lot more cautious, and I want it to be able to drive on left and the right side of the road. And so what essentially this lane signal would be it would randomly flash. Let's suppose the car is suddenly flashed to go left, so it would, if it's in the left lane, it should stay in the left lane, and if it's in the right lane, I would want it to go over to the left lane. And if it's in the left lane and it flashes right, I would hope that it would go towards the right lane. So that would be the future of the project that I think would be a nice addition to have. So if anyone wants the actual weights file and the model file, just let me know. I'll be happy to put it up on Google Drive. The actual weights file is about 11 megabytes, so it's fairly large. And you also need Keras, by the way, so make sure you have Keras installed for Python. You can play around with it if you like. Anyways, thanks for watching. There's clearly a lot more work to be done here.